I want to thank Frank for suggesting a brilliant idea. Frank thought that it would be really cool if we ran BGP towards the service provider environment on Gigabit Ethernet 2. I mean, it's an MPLS environment, so it makes perfect sense that that would end up being some type of solution that we'd want to implement. So I've decided to make that operation episode 3 of this series, and we're going to dive into it right now. Taking Frank's suggestion, what we're going to do is we're going to go through the steps necessary to enable BGP on C-Edge 1 and C-Edge 11. So this shouldn't be C-Edge 2, it should be C-Edge 11. And the MPLS router. Now, I've broken this up into a series of steps. And what we're going to do is we're going to first start with step 1. Step 1 is we're going to do the configuration on the MPLS router. And what we're going to do here is we have set up the router BGP 1000 per the config. And now what I want to do is I want to build my neighbor statements in order to be able to form my connections. So I'm going to do a neighbor 240.1.1. And in this case, it's going to end up being 14. So that's the IP address of C-Edge 1, first issuable 13, which is going to end up being on this device. And then 14 is the neighbor. And this is going to end up being in remote autonomous system. And what I want to do at this juncture is we're just going to go ahead and call this 100. And what we'll do is we'll call C-Edge 11. We'll call it 101, since it's going to be branch 1. So this will ultimately be our data center. We're going to go ahead and call it AS 100 since it's site 100. Since C-Edge 11 is going to be site 1, we're going to call it 101. So that's the way we're going to try to form our peering. I'm just going to go ahead and do neighbor 40.1.1, and we will go ahead and say this is going to be 18 for remote AS of 101, as I said. So now the other thing that I want to do is I want to advertise my interfaces into BGP for the purposes of exchange, the plan being to ultimately learn those routes on C-Edge 1 and C-Edge 11. So let's go ahead and do that. So what I'm going to do is I'm going to go ahead and say network 4110, and we'll have to say 41.1.12 with a net mask or a mask of, let's go ahead and say 255.255.255.252. And we will go ahead and take the network of 16. 255.255.255.2. Now, the object of the exercise here is, again, to try to bring up our neighbor relationships. I'm using physical interfaces to try to form these peering relationships instead of a loopback, but, that's perfectly fine here as far as just trying to get the protocol up. Now, typically in most classes, we pretend that MPLS is just a MPLS environment, but at the end of the day, it's either a cloud or a router. And if we wanted, we could expand MPLS and we could actually have a PE router, P routers, and build everything out and do the multi-protocol label switching environment. But at this juncture, all I really want to do is just pretend that it's an MPLS environment and bring up these BGP peerings. So let's go ahead and say show IP BGP summary. And we can see here that we're trying to form a peering relationship with 14 and 18. So again, the addressing should have been for 17 on my interface, 18. So yes, those addresses are correct. So 13 and 17 are local, and the remote addresses are located on the only other available IP address in the subnet of /30. All right, so the next step, let's go ahead and take a look at the procedure. So we created the BGP configuration on the MPLS. Now what we need to do is we need to create a BGP feature template to support eBGP peering using device-specific variables. So what I'm going to do is I'm actually going to highlight step 1, and I'm going to basically take it out of bold. I'm just trying to keep a way of trying to check which tasks have been done. And at the end of the day, this might not be the best way, but it is a way. All right, so what we want to do now is create that feature template. Now, to do that, I need to navigate to my SD-WAN manager. I'm going to log into it and skip for now. I'm going to take a look at the configuration here. So we're going to go to menu configuration down to classic. We're going to go to templates. From templates, we're going to navigate to feature templates. And I need to create a new one. So I'm going to add a new feature template. That new feature template is going to be for a C8000V. I'm going to navigate all the way down to the bottom list of other templates, and we'll see I can create a feature template for Cisco BGP. And we're going to go ahead and make one. I'm going to try to stick to just the minimum requirements to get this set up. So let's go ahead and select the config. I'm going to go ahead and say custom -BGP -template. To satisfy the description, I'll just copy and paste that like usual. And what we want to do, first of all, is look at our basic information. So we can see here, it's asking us for a device-specific variable to start with. And in the configuration here, our shutdown default is no. We can see that that's selected there. It's kind of grayed out, but we can see it. I don't like this variable name, so I'm going to change it. I'm going to change it to my local ASN. And ultimately, I'm going to need to know how to connect to it via the remote ASN. So right now, we're going to leave propagate AS path and all of that stuff unchecked. We're going to go ahead and ignore the address family. We are going to then take a look at the neighbor config. So I need to configure my neighbor statement. And again, this neighbor statement is going to end up having to be a variable. Now, BGP neighbor address, I kind of like that name, so I'm going to stick with it. The remote autonomous system, so BGP neighbor remote AS. I kind of like it. It's long, but we'll go ahead and keep it since it does make sense. And address family right now is not going to be turned on. So all I'm going to do is select add. So we've got it in place there. It's showing up as a line item, and I'm just going to go ahead and say save. So now we have the feature template. Let's take a look at the next step. So we created the BGP feature template to support eBGP with variables. So the next step is to detach CEdge 1 and CEdge 11 from the device template. So step 3, configuration, templates, device template, ellipses, detached devices. The two that I wish to detach are going to be the two that I have. We'll detach those, and we'll have to wait for this to complete before we proceed. We can see that it succeeds, thus, hopefully, completing that step. So we'll go and look at the next one. So the next step, this one is now done. Step 4, edit the VPN feature template to remove the second default route for gigabit 2. No problem. Let's go ahead and navigate once more to configuration, to templates, to feature templates. We're going to search for the VPN0 template. So we're looking at the VPN, Cisco VPN, not the interface template. We want the VPN0 template. That's where we created that default route. We're going to go ahead and edit it. To edit it, we're going to go to IPv4 route. I'm going to edit. We'll go to the next hop value here. And what we're going to do is we're going to find gigabit Ethernet 2, and we're going to delete it. Save those changes. Save changes. And update. Now, seeing as that we have detached the devices from the template, it's not going to force a change, thus kind of facilitating things a little bit. So what we have done is we've completed step 4. Edit the device template to include the new BGP feature template. Again, easy peasy. Configuration, templates, device template this time, 3 dots, edit, navigate down to the Transport and Management VPN. From the Transport and Management VPN, what we want to do is we are going to add OSPF. So to add add BGP, we'll just simply select BGP, and we need to choose that feature template, custom BGP template, and we will go ahead and update. Let's take a look at the next task. Let's go ahead and mark this one as done. Attach CEdge 1 and CEdge 11 to the modified device template. That means I'm going to have to provide the information for the variables. But again, not difficult. We'll go to more options. We will say attach devices, select the 2, CEdge 1, CEdge 11. Transfer them to the selected devices, hit attach. Provide the information. So for CEdge 1, I'm just going to do it over here. From CEdge 1's perspective, I need to have the local autonomous system I'm going to use, which is going to be 1000. Now, I could have hard-coded that. Actually, no, the local would be for CEdge 11 in this case, which we said was going to be CEdge 1 is 100. CEdge 11 will be 101. So my remote autonomous system that I'm going to form a peering relationship with is going to be 1000. So that's going to end up being the MPLS device. And I need the neighbor address, which I know is a 39.1.1. And we can see here, my gateway of last resort is going to end up being 13. So instead, the address will be 40 since it's MPLS 1.1.13. So I'm actually going to form a peer with my gateway of last resort for what would have been VPN or would have been the 40 address. So that should satisfy the requirement. So the next thing I want to do is let's go ahead and provide the same information for our other device. So the remote AS we're forming a peering relationship with is going to be 1000. The address, BGP neighbor address, is going to end up being 40.1.1.17. That's going to end up being the only other address in the 16/30. And my local autonomous system number is going to be 101 since I'm going to be in Site 1. I know I'm in Site 1 because of this right here. Now, sometimes I use the autonomous system numbers that I choose to use as the site IDs, and that kind of falls in line with what they do in the CCIE exam. So right now, what I'm going to do is I'm going to go ahead and apply this. We need to wait for the configuration to be pushed to the devices using those DTLS tunnels, leveraging the capability of netconf, as we've discussed before. But once that's done, what we want to do is we want to go ahead and see if we get our BGP peerings up and operational. And we also want to look at the next step, which I think is going to end up being verifying. So we'll go ahead and do update. We'll select next. We'll configure the devices. I'll confirm that I want to apply the configuration to 2 devices, and we will monitor it. Once it shows up, I'll just go ahead and click the log, and we'll watch it. Okay, it looks like it has been applied. So the next step will be to verify to see if the peerings come up. So we'll go ahead and mark this as done. So verify the BGP peering and validate the impact on the SD-WAN overlay. Now remember, the overlay is going to end up being our tunnels. So in this case, IPsec tunnels. The BGP peering obviously needs to come up, and we want to make certain that we are learning about the other networks in order to be able to assure reachability. So let's jump over to our MPLS environment. So I'm on MPLS, and we can see our neighbors did indeed come up. If I say EN and I say show IP BGP summary, we can see the status here. We're not learning any routes, but I do want to know if I'm advertising routes. So just as a quick check, I'm going to say show IP BGP, and we're going to say neighbor 40.1.1.14 advertised routes. And we can see that I'm advertising both of the routes that I have locally to that device. And we'll go ahead and double check what we're sending to 18. So we're sending the same routes to C-Edge 11. So let's go ahead and take a look at the routing on C-Edge 11. So all I'm going to do is admin 1234 QWER. I think I hit the E. Nope, I didn't. Fat fingered it. So we'll wait for it. Admin 1234 QWER. EN. Now remember, on an iOS XE device, VPN0 is the global routing table. So all I'm going to do is I'm going to type show IP route and just hit enter. Specifically, I want to know, am I learning any BGP prefixes? Now, the only BGP prefix that should show up in the list is going to end up being the BGP prefix that I'm learning that is being advertised to me from the MPLS router, which is obviously not going to be my interface. I'm not going to learn about my network via BGP because it's locally connected. So let's take a look and make sure that is indeed the case. So here I'm learning about the network of 40.1.1.12 with regard to reachability. So let's go ahead and say, can I ping 40.1.1.12? But bear in mind, that's the network. So the gateway is 13. So the device should be 40. So let's see if we've got reachability to it. And as such, what I should now see is I should still have peers with regard to my tunnels. So I'm going to go ahead and say show SD-WAN. We're going to say BFD sessions to look at those. And I still have both of those tunnels up and operational. And the information should be able to be exchanged across both of these transports. So what we just did is demonstrate beyond a shadow of a doubt that it's not hard to run a routing protocol towards the transport side. It's not, since it's not difficult, that's not the reason that we don't do it. So if it was hard, obviously, in most classes, especially official classes, we don't run a routing protocol because it's just another level of complication that we want to take off the table, because learning SD-WAN, while it's new to us, is complicated enough. But like I said, I'm perfectly happy to take suggestions from the people that are watching the videos and try to incorporate those into the episodic series. So I guess this would conclude what I'm going to be calling episode 3, which is going to be enabling BGP on the transport side of our C-Edge devices. So again, keep the suggestions coming. I'll try to incorporate them into the build process. Right now, I'm just have the 6, unless somebody makes a suggestion that is going to be something that I'll entertain basically inserting in my current order. But as it stands right now, I know I'm going to be facing at least 6 episodes. Some people have made suggestions about MPLS. Some people have made suggestions about, rendezvous point assignments inside of the overlay. All of those are fantastic questions, as well as fantastic lab opportunities. So if we can evolve the environment to the point where we can get there, then definitely it's something that I want to entertain in these videos. So I'm going to go ahead and stop here instead of talking everybody to death. I think this one's actually going to be less than an hour long. And in that case, I'm going to go ahead and wrap here, and I'll hope to see everyone in the next video. Till then, take care.